Hello kings and queens, welcome back to the channel. So in this video today we are going to discuss about how to solve the transportation problem using Modi method. So before starting the problem, let's have a brief introduction about this Modi method. So Modi method is highly used to find the optimality of the initial basic feasible solution, and Modi method is highly used to find out the minimum solution for the transportation problem. So this method is used to find what is the best way to reduce the transportation cost. Before starting this transportation problem using any method, the first step which you have to do is you have to identify whether it is a balanced problem or unbalanced problem. So if it is a balanced problem, the total demand and the total supply will be equal. If it is an unbalanced problem, the total demand and also the total supply will not be equal. So let's identify whether it is a balanced or unbalanced problem. So total supply is equals to 250, which means I'm taking the values of the supply 250 plus 350 plus 400, which is equals to 1000. And let me sum up the total demand. So total demand is equals to 200 plus 300 plus 350 plus 150, which is also equals to 1000. Here the demand and supply is equal, which means it is a balanced problem. So let me write the total here, that is 1000. Modi method can be divided into two phases. Okay, in the first phase, we will identify the initial basic feasible solution by using any methods like northwest corner method or else least cost method or Ogle's approximation method. And in the second phase, we will apply this Modi method in order to find whether the initial basic feasible solution is optimum or should we make any improvement in the solution. Okay, so let's do the first phase. Okay, let me write it step by step. Okay, first step. The first step is finding the initial basic feasible solution by using any method. In question paper, sometimes they would have mentioned like use northwest corner method or Ogle's method or least cost method. In this question, they have not mentioned anything. So I will be using the most easiest method, that is northwest corner method. Okay. First step is finding the initial basic feasible solution by northwest corner method. So if you are familiar with any of the methods like least cost Ogle's approximation method, you can even use that. So in the first step, we are going to solve the problem in a normal way as we did in the last video. Okay, so using northwest corner method, first we are going to identify the transportation cost, that is initial basic feasible solution. Okay, let me start with the northwest corner method. In this question, ABC is a product, PQRS is a destination. So this is supply, this is demand, and it is a balanced problem because the demand and supply is equal, that is 1000. Okay, so let me start with the solution. So in the northwest corner method, first we will be identifying which is the northwest. So in this problem, the northwest is this. So I have selected this cell for allocation. Next, what I have to do is I have to check with the demand and supply. The demand is 200 and the supply is 250. The minimum is 200. The minimum value is 200. So I will allocate that 200. So I have given everything in this demand and I have to deduct the 200 from 250. So 250 minus 200, which is equals to 50. As I have given everything in this column, it should be striked off. I have striked off this column. So the remaining area is this much in this matrix. So the northwest corner is here. So I will select this cell for allocation. Now we have to check with the demand and supply. The demand is 300 and the supply is 50. So the minimum value is 50. So I will allocate that 50. And I will strike off this because I have given everything here. So I have to deduct that 50 from 300. So 300 minus 50, which is equals to 250. As I have given everything in this row, I have to strike off it. Okay, I will strike off this row as well. Next, the remaining region is this much. In this, the northwest corner lies here, and we have to check with the demand and supply. The demand is 250 and the supply is 350. The minimum number or the minimum value is 250, so I will allocate that 250, and I have given everything here. Now I have to deduct the 250 from 350, so 350 minus 250 is equals to 100. Okay, as I have given everything in this column, I should strike off this. Okay, so the remaining region is this much. Here, the northwest corner is here. We have to check with the demand and supply. The demand is 350 and the supply is 100. The minimum value is 100, so I will allocate that 100. I have given everything here, so I will strike off this and I have to deduct that 100 from 350. So 350 minus 100, which is equals to 250. As I have given everything in this row, I will strike off this row. Okay, so the remaining part is 3 and 2. Among this, the northwest corner is here. So in this, the demand is 250 and the supply, which is corresponding to 3, is 400. So the minimum value is 250. So I will allocate that 250 and I have given entirely. So I will cancel that and I should deduct the 250 from 400. So 400 minus 250, which is equals to 150. Okay, I have given everything in this column. So I will strike off this column. So the remaining is 2. We have to do the allocation there and we have to check the demand and supply. The demand is 150 as well as the supply is 150. So it balance each other. The demand and supply is equal. So I will allocate that 150 here. I have satisfied this as well as this. So I will strike off that. Okay, so at the end of the allocation, you have to get the demand and supply equal. If you get that, it indicates that your allocations are correct. Okay, so this much is about the allocation. Next, what we have to do is we have to identify whether it is a degenerate or non-degenerate basic solution. Okay, so the step 2. Second step is to identify whether it is a degenerate or non-degenerate basic feasible solution. Okay, for that we have to use the formula m plus n minus 1. Okay, m indicates the rows and n indicates the number of columns. Okay, so in this the number of rows is A, B and C, which means 1, 2 and 3. So m is 3 plus n is column. We have to identify how much column is there in this particular problem. But here what we have to do is we should not consider this demand as row and supply as using this formula m plus n minus 1. You should avoid this demand and supply. You should not consider this demand and supply as a row and column. Okay, so here the number of rows is A, B and C, which means 1, 2 and 3. The number of columns, that is n, is P, Q, R and S, which means 1, 2, 3 and 4. So the n is 4. So 3 plus 4 minus 1. 3 plus 4 is 7. 7 minus 1 is 6. So the answer which we got from m plus n minus 1 is 6. Next, if we want to find out whether it is a degenerate or non-degenerate solution, what we have to check is we have to check with the allocations. We have to identify whether we have allotted 6 cells. If we have allotted 6 cells, then it indicates that it is a non-degenerate solution. If our allocation is less than 6 or more than 6, then it will be called as a degenerate solution. So let's identify how much we have allocated. Okay. So we have allocated here, here, here and here. So let me count how much allocations is there. 1, 2, 3, 4, 5 and 6. So the number of allocations is also 6. You should not count all the values inside this matrix. You have to count only the cells where you have allotted. So I have allotted here. So 1, 2, 3, 4, 5 and 6. So the number of allotment is 6. Let me write that also. The number of allotments equals to 6. So m plus n minus 1 is also 6. Number of allotments is also 6. Therefore, it is a non-degenerate solution. Okay, we are done with the step 2. Next. So the third step is finding the optimal solution using Modi method. So why this optimal solution is identified is we have to ensure whether the initial basic feasible solution is optimum or should we make any further improvement in the solution in order to reduce the transportation cost. So through this Modi method we will be identifying the optimum solution, that is the minimal solution or the minimal cost for the transportation problem. So in this step we have to write down the table as it is. We did the northwest corner rule method, no? So the same table we have to write. We have to write the allotments, values, everything. But we have to avoid the demand and supply because in this step it is not necessary. Demand and supply is necessary. So just we will avoid that and we have to write the entire matrix. So in this step what we have to do is we have to identify the U and V value. So U and V value, here U is represented as a row and V is represented as a column. So V is represented as a column and U is represented as a row. So this row will be represented as U1 and this row will be represented as U2 and this will be represented as U3 and this as V1 because it is a column. So this is V2, V3 and V4. So we have to find out the values of U and V just for the occupied cells. So occupied cells means the cells which is allotted is known as occupied cells. So in this matrix the allotted cells are 3, 1, 7, 6, 5, 9, 3 and 2. So these are the allotted cells. 2, 8, 7, 4, 9 or unallotted cells, that is unoccupied cells. We are finding out the values of U and V just for the allotted. Cij is equals to Uj plus Vi. So this will be our formula. So using this formula, we will be identifying the U and V value. So the formula is Cij is equals to Ui plus Vj. So here Cij means the values inside the matrix like 3, 1, 7, 4, 2, 6, 5, 9, 8, 3, 3, 2 are the Cij values. So we will be calling the values which is there inside the matrix as Cij. And this is U and this is V. So using this formula, we will be finding out the U and V values just for the occupied cells, that is allotted cells. So let's start it one by one. But here we don't have any U values and any V values. So we require any one U1 values or V2 values or U2, U3, V4, V3, V1, any one value if we want to compute this formula. So for that, what we have to do is, let me take 0 for the row or the column which have maximum allocation. So if I take this row, the maximum allocation is 2. So the maximum allotted or the occupied cell is 2. When I take this row, the maximum allotted cell is 2. In this row also, the maximum allotted cell is 2. So all the rows in this cell are equally allotted, so nothing is greater, so everything is equal. So I can take 0 for any u. So I can take 0 for u1, I can take 0 for u2, or I can take 0 for u3. So I will allot 0 for u1. Okay, so now u1 is 0. So using this value, I can easily identify other value like u2, u3 and v values. Okay, so let's compute this Cij formula. So as I said, Cij is the values inside the matrix. So in this row, the first allotted cell is 3. Okay, so the first allotted cell is 3. 3 is equals to, I want ui value for this. So the u for 3 is this one. So the u value for 3 is this. Okay, so I will write 0 plus I want vj value. So the v value for 3 is this, but I don't have v1 value. So I have to identify this vj value now. So vj is equals to, if I transfer this 0 to left side, so the plus 0 will become minus 0. So 3 minus 0 is 3. Here the Vj value is 3. So I will write V1 value as 3. Okay, we are just using this formula only for the occupied cells. Okay, the second occupied cell in the first row is 1. So the Cij value is 1. 1 is equals to, so the u value for 1 is 0 plus the v value for 1 is not yet known. So I will write C, that is Vj. Okay, so I want Vj value now. So if I transfer this 0 to left side, it will become minus 0. So the value will be 1. So 1 minus 0 is 1. So the V2 value is 1. So in this row, there is no other occupied cell. So I will move on to the next row. So in this row, the occupied cell is 6. We will not consider this 2 because it is not an occupied cell. It is an unoccupied cell. So this formula is not suitable for the unoccupied cell. So I will not consider that. So the next occupied cell is 6. So the Cij value is, the u value for 6 is not known. So I will write u as same plus the v value for 6 is 1. Okay, so if I transfer this 1 to here, the plus 1 will become minus 1. So 6 minus 1 is equals to ui. So the 6 minus 1 is 5. So the ui value is 5. So I will write 5 here. Okay, so the next occupied cell is 5. So the Cij is 5. 5 is equals to, the u value for 5 is 5 plus the v value for 5 is not known. So I will write Vj as same. So if I transfer this 5 to left side, the plus 5 will become minus 5. So 5 minus 5 is 0. So the Vj value is 0. So the V3 value for 5 is 0. Okay. Here I don't have any other occupied cell. So I will move to the next row. So in this row, 8 is not occupied, 3 is also not occupied. So the next occupied cell is 3. So the Cij value is 3. 3 is equals to, the u value for 3 is not yet known. So I will write that u as same plus the v value for 3 is 0. So the v value for 3 is 0. So I will write that 0 here. So if I transfer this 0 to here, the plus 0 will become minus 0. So 3 minus 0 is equals to ui. So 3 minus 0 is 3. Okay. So the ui value is 3. Next, the next occupied cell is 2. So the Cij value is 2. 2 is equals to, the u value for 2 is 3. 3 plus the v value for 2 is not yet known. So I will write that as same, that is Vj. So when I transfer this 3 to left side, the plus 3 will become minus 3. So 2 minus 3 is minus 1. Right? So 2 minus 3 is minus 1. Here the V4 value is minus 1. So this is very simple. You have to know which is Cij, and for the maximum allotted row or the maximum allotted column, you have to take 0. In case in this column, if I have 3 allotted cell, then I can write V1 as 0. If in case if this B row is having maximum allocation, that is if B is having a 4 or if it has 3 allocation when compared to other rows, then the U2 value will become 0. Here all the rows have equal allotment, so I can take 0 for any U value, that is U1, U2, U3. So I have taken U1 as 0. So we have identified this U and V value. The next thing which we have to do is, we have to identify. So the next step is to identify the delta Ij for the unoccupied cells. So the unoccupied cells in this matrix are 7, 4, 2, 9, 8, 3. So these are the unoccupied cells. So for this unoccupied cell, we are finding out this delta Ij by using this formula Cij minus Ui plus Vj. So let's start computing this Cij formula. So the first unoccupied cell is 7. So as I said, U is row and V is column. So Ui is row and Vj is column. So let me represent this 7 as X. The row is 1 and the column is 1, 2 and 3. So the column is 3. So the 7 lies in the first row and the third column. So I am representing this 7 as x13, that is first row and third column, is equals to the Cij value is 7. 7 minus the u value for 7 is 0. 0 plus the v value for 7 is 0. Okay, did you got my point? So the Cij value is 7. The u value for this 7 is 0 and the v value for this 7 is 0. So 0 plus 0 is 0. So 7 minus 0 is 7. And let me move towards the next unoccupied cell. So the next unoccupied cell is 4. So this will be represented as x14. So x14, which means it lies in the first row and fourth column. Okay, so the Cij value is 4. 4 minus the u value for this 4 is 0. 0 plus the v value for this 4 is minus 1. Okay, let me simplify this. So 4 minus 0 plus into minus 1. Plus into minus is minus. So 0 minus 1 is minus 1. So 4 minus of minus 1 is 5, which means minus minus will become plus. So 4 plus 1 is 5. So 4 plus 1. How means this minus and minus will become plus. Okay, next the third unoccupied cell is 2. This will be represented as x1 and 1, which because it lies in the row 1 and column 1. So plus into minus is minus. So 0 minus 1 is minus 1. So 4 minus of minus 1 is 5, which means minus minus will become plus. So 4 plus 1 is 5. So 4 plus 1. How means this minus and minus will become plus. So the next unoccupied cell is 2. Okay, so this 2 will be represented as x2 and 1 because this 2 lies in the second row and first column. So it will be represented as x2, 1. So the Cij value is 2. 2 minus the u value for this 2 is 5. 5 plus the v value for this 2 is 3. Okay, let me simplify this. 2 minus 5 plus 3 is 8. So what we have to do now is 2 minus 8. 2 minus 8 is 6. Minus 6. Okay. So the next unoccupied cell in the second row is 9. So this will be represented as x24 because it lies in the second row and fourth column. So the Cij value is 9. 9 minus the u value for this 9 is 5. 5 plus the v value for this 9 is minus 1. Let's simplify this. So 9 minus plus into minus is minus. So 5 minus 1 is 4. So 9 minus 4 is 5. Okay. So the next unoccupied cell is 8. So this will be represented as 3 1 because it lies in the third row and first column. So x31 is equals to the Cij value is 8. 8 minus the u value for this 8 is 3 and the v value for this 8 is also 3. So 8 minus 3 plus 3 is 6. So 8 minus 6 is 2. Okay, so the next unoccupied cell is 3. So this can be represented as x3 and 2. So x3 2 because it lies in the third row and second column. So the Cij value is 3. So 3 minus the u value for this 3 is 3 plus the v value for this 3 is 1. So 3 minus 4. So 3 minus 4 is minus 1. So if the solution want to be a optimum solution, the delta ij value, which means all the delta ij values should be equal to 0 or it should be greater than 0. But in this case, we have some negative values like minus 6 and minus 1. So if this solution want to be an optimum solution, the delta ij value, all the delta ij values should be equal to 0 or it should be greater than 0. So there should be no negative value. But in this case, we have two negative value. So among this negative value, we have to select the most least negative value. So the most least negative value among this delta ij is this. So this is the most least negative value. So I will select this particular cell. So this cell lies in the second row and first column. Second row and first column. So I will select this cell. So using this cell, we have to do the looping techniques to get the optimum solution. So now I have selected this cell for the looping techniques. So the first rule of this loop is it should be a closed loop like this. It should not be a open loop. It should have corners. Okay, like this it should have corners. Okay. So this is the cell which we have selected. So from this cell we have to do the loop. So the second rule of this loop is it should attach only the allotted cell or the occupied cell. For example, so this is the selected cell. In case the cell which is after to the selected cell does not have any allocation, it should not be considered. Then the line should move on to the next cell. So the first rule is it should be a closed loop, and the second condition is the loop should attach only the allotted cell. It should not attach any unoccupied cells, unallotted cells. So in case, for example, so this is the selected cell. So the cell which is after this selected cell should be allotted cell. If it is not a allotted cell, then the loop line should continue to the next cell where the cell is allotted. But in this case, we have allotted cell. So we should see whether we can do loop here. So the loop will start here. The next cell is allotted cell. So I have got one corner. So next I will move towards up. So this is also a allotted cell. So this is the second corner. And next I will move towards like this. This is also a corner which is allotted cell. Next I will close like this. And the third rule is the loop should start and end at the same point. So for example, now it is started in this cell, again it went like this, like this, like this, and came towards the same selected cell. So the starting and end point of the loop should be same. It should connect only the allotted cells, and it should have corners, and it should select only the allotted cell. For in case if this is not allotted cell means, then the loop should move towards the next cell. For in case if this is also not allotted cell means, the line should move towards the next cell where the cell is allotted, and it should have corners, 4 corners. Okay, so this will be indicated as plus x, and this will be indicated as minus x, this will be indicated as plus x, and this will be represented as minus x. Okay, so now we have to consider only the minus x cells. So in this 4 corners, the minus x cells are this and this. So the allotted values in this cell is 200 and 250. So now what we have to do is we have to find out the minimum of 200 and 250. So this is one minus x value, and this is another minus x value. So among this, the minimum is 200. So I will select this 200. So using this 200, we have to add to the plus x value cell, and also we have to deduct this 200 from the minus x value cell. So now the x value is 200. So this is minus x, right? So 200 minus 200 is 0. So I will not allot anything here. So this is plus x. So 200 plus 50 is 250. So I have to allot this as 250. Next is plus x. So here I don't have any allocations. So this will be directly written as 200 plus x. So let me consider this as a 0. So 0 plus 200 is 200. Okay. Next is minus x. So where I have to deduct this 200. So 250 minus 200 is 50. So this will be our modified allocations, and remaining cells we have to write as the same allotments. So 100, for 3 it is 250, and for 2 it is 150. So now again we have to identify the u and v value. So this will be represented as u1, this as u2, this is u3, and this is v1, this is v2, this is v3, and this is v4. So let me check row wise which row is having a maximum allocation. So in this row the allocation is 1, and in this the allocations are 3 cells, and in this the allocations is 2 cells. So the maximum allocation is the second row. So the second row holds a maximum allocation. So I will write this u2 as 0. Okay, so you have to again use the formula, that is Cij is equals to u plus vj. That Cij formula is just used for the occupied cells. So in the first row, the first occupied cell is 1. So the Cij value is 1. 1 is, so here we don't know the value of u and v. So let me keep that as it is. Let me calculate this second row occupied cells. So in the second row, the first occupied cell is 2. So the Cij value is 2. 2 is equals to, so the u value for this 2 is 0. 0 plus the v value for this 2 is not yet known. So if I transfer this 0, it will become plus 0 will become minus 0. So 2 minus 0 is equal to the vj value. So 2 minus 0 is 2. So the vj value is 2. So I will write it as 2. Okay, so the second occupied cell in the second row is 6. So the Cij value is 6, and the u value for 6 is 0, plus I don't know the vj value. So if I transfer this 0 to that side, it will become minus 0. So the value will be 6 minus 0 is 0. So the value for v2 is 6. So the third occupied cell in the second row is 5. So the Cij value is 5, and the u for 5 is 0, plus the v value for 5 is vj. So if I transfer this 0 that side, it will become a minus 0. So 5 minus 0 is 5. So the vj value is 5. Okay. Now let me move on to the first occupied cell, because I have got the v2 value. Now just I have to identify the u1 value. So the ui value is not yet known. So the v value for this one is 6. So if I transfer this 6 to the left side, the plus 6 will become minus 6. So 1 minus 6 is minus 5. So the UI value is minus 5. Okay, so let me move on to the third row allocation. So the occupied cell in the third row is 3. So the Cij value is 3. 3 is equals to the U value for 3 is not yet known plus the V value for 3 is 5. So if I transfer this 5 to the left side, it will become minus 5. So 3 minus 5 is minus 2. So the U value for this 3 is minus 2. So the next allotted cell is 2. So the Cij value is 2 and the U value for 2 is minus 2 plus the V value is not yet known. Okay, so if I transfer this minus 2 to the left side, it will become plus 2. So 2 plus 2 is 4. So the V value, so the Vj value for 2 is 4. So now we have got U1, U2, U3, V1, V2, V3 and V4 values. The next thing which we have to do is we have to find the values for the unoccupied cells. So the unoccupied cells in this matrix are 7, 4, 9, 8 and 3. Okay, so let me calculate that. For that what we have to do is we have to use the formula, that is delta Ij is equals to Cij minus Ui plus Vj. Okay, so the first unoccupied cell in this row is 3. So the Cij value is 3, 3 minus the U value for 3 is minus 5 plus the V value for 3 is 2. So minus into plus will become minus. So 5 minus 2 is minus 3. So the minus and minus will become plus. So 3 plus 3 is equals to 6. Okay. So this will be represented as x, 1 and 1 because it lies in the first row and first column. So 1, 1. So the next occupied cell in this row is 7. So it can be represented as x1, 3 because it lies in the first row and third column. And the Cij value is 7 and the U value for this is minus 5 plus the V value for 7 is 5. So minus 5 plus 5 will become 0. So 7 minus 0 is 7. So the next unoccupied cell is 4. So it will be represented as 1, 4. So the Cij value is 4. So 4 and the U value is minus 5 and the V value is 4. So minus 5 plus 4 will be minus 1. So minus 1. So minus and minus will become plus. So 4 plus 1 is 5. The next unoccupied cell in the second row is 9. So it will be represented as 2, 4 and the Cij value is 9. 9 minus the U value is 0 plus the V value for 9 is 4. So 0 plus 4 is 4. So 9 minus 4 is 5. So the next unoccupied cell is x, 3, 1. So because it lies in the third row and first column. So 3, 1 is equals to the Cij value is 8. 8 minus the U value is minus 2 plus the V value is 2. So minus 2 plus 2 will become 0. So 8 minus 0 is 8. So the next unoccupied cell is this. It lies in the third row and second column. So the Cij value is 3. 3 minus the U value for 3 is minus 2 plus the V value is 6. So minus 2 plus 6 will be 3 minus 4. So 3 minus 4 will be minus 1. So the conditions to get an optimum solution is we should have all the values which is equal to 0 or greater than 0. But in this delta Ij value, we have one negative value, that is this minus 1. So all other values are more than 0. This minus 1 lies in the cell x32, third row and second column. So this cell. Now we have to again apply the loop. So the loop should have 4 corners and it should join only the allotted cell, and the loop should start from one cell and it should end at the same cell. So here we have one corner, Here we have one corner, here also we have one corner. Again, it should end at the same point. So this will be represented as plus x, this as minus x, this as plus x, and this will be represented as minus x. So the x values are 50 and 250. So among this, the least value is 50. So using this 50, we have to do a modified solution. That means we have to do the deductions and additions. So using this 50, we have to add and deduct this looped cells. Okay, so the 6 is having a 50 value, and this will be the value of x. So 50 minus 50, because this is a minus cell, so 50 minus 50 is 0. So the 6 is 0, so we will not allot anything. And here the 5 is having a allotment of 100, and this is a plus cell. So 100 plus 50 is 150. So 5 holds a allotment of 150. Next, 3. 3 is having a plus sign. So we don't have any value or any allotment. So it will be considered as plus. So 50. So 0 plus 50 is 50. So the allotment is 50. And in the next cell, the allotment is 250, but this is a negative cell, which is minus x cell. So 250 minus 50 is 200. So 300 holds a allotment of 200. So for the remaining cells, we have to do the allotments which was there in the previous table. So 1 holds allotment of 250 and 2 holds allotment of 200 and 2 holds the allotment of 150. Okay, so again we have to identify the u values here. Until we get a optimum solution, we have to identify the u and v value. So among this matrix, the row which holds a maximum allocation is third row. So it will be represented as 0. And now we have to use the formula, that is Cij is equals to Ui plus Vj. So in the first row, the occupied cell is 1. So the Cij value is 1. So 1 is equals to, the U value is not yet known. We don't even know the value of. For the second row also, we don't have u and v value, but when we consider this third row, we have u value. So let me take the allotment of this table first. So in the third row, the first occupied cell is 3. So the Cij value is 3. 3 is equals to, the u value for 3 is 0, plus we don't know the value of v2. So Vij. So when I transfer this 0 here, it will become 3. So 3 minus 0 is 3. So the value of v2 is 3. So the second allotted cell is 3. So the u value for this 3 is 0, and the v value we don't know. So when I transfer that 0 here, it will become 3. So this value is also 3. So the next occupied cell is 2. The u value is 0, plus I don't know the vj value. So when I transfer this plus 0, it will become a minus 0. So the answer will be 2. So the v4 value is 2. So now I got to know the v2 value, which will be helpful to identify this one occupied cell. So for this one, the u value is not yet known, and the v value for 1 is 3. So when I transfer this 3 that side, it will become minus 3. So 1 minus 3 is equals to ui, which means 1 minus 3 is minus 2. So the ui value is minus 2. Next, for this row, the allotted cell is 2. So the Cij value is 2, and the u value is not yet known, plus the v value for this 2 is also not yet known. So let me wait until I get u value, so I can compute it. So the second allotted cell in this row is 5. So the Cij value is 5. 5 is equals to, I don't know the u value, plus I know the v value. So the v value is 3. When I transfer this 3, the positive 3 will become negative 3. So 5 minus 3 is 2. So the u value is 2. Now I can compute this. So the Cij value is 2, plus the u value is 2, plus I don't know the v value. So I will write it as c. So when I transfer this 2 to left side, the plus 2 will become minus 2. So 2 minus 2 is 0. So the u value is 0. So now I got all the u and v value. Now what I have to do is, again I have to use the delta ij formula for the unoccupied cells. So this formula is Cij minus ui plus vj for the unoccupied cells. So in the first row, the unoccupied cell is 3. So the Cij value is 3. It is represented as x11 because it lies in the first row and first column. So the uij value is minus 2 plus the v value for this is 0. So let me compute it. Minus 2 plus 0 will become minus 2. So minus into minus will become plus. So 3 plus 2 is, so the second unallotted cell is 7. It will be represented as x13. So the Cij value is 7 and the u value is minus 2 and the v value is 3. So minus 2 plus 3 will become 1. So 7 minus of plus 1. So minus into plus will become minus. So 7 minus 1 is 6. So the next unallotted cell is 4. It will be represented as 1, 4. So the Cij value is 4 and the u value is minus 2 plus the v value is 2. So minus 2 plus 2 will become 0. So 4 minus 0 is 4. So the next unallotted cell is 6. So it will be considered as x22 because it lies in the second row and second column. So the Cij value is 6 and the u value is 2 plus the v value is 3. So 2 plus 3 is 5. So 6 minus 5 is 1. And the next unallotted cell is 2, 4, that is 9. So the Cij value is 9 and the u2 value is 2 plus the v value for 9 is 2. So 2 plus 2 is 4. So 9 minus 4 is 5. And the next unallotted cell is 8. It will be represented as x31. So the Cij value is 8 and the u value is 0 plus the v value is also 0. So 8 minus 0 is 8. Now you can see there is no negative value. 5, 6, 4, 1, 5 and 8. There is no negative value, which means we have got a optimum solution. Will be, since all delta I is greater than 0, solution is optimum and unique. So at the end so after writing the conclusion, you have to multiply the units with the amounts. So using the last matrix, you have to identify the transportation cost, that is 1 into 250, 2 into 200, 5 into 150, 3 into 50, 3 into 200 and 2 into 150. So 1 into 250 is 250, 2 into 200 is 400, 5 into 150 is 750, 3 into 50 is 150, 3 into 200 is 600 and 2 into 150 is 300. So if you add all this, you will be getting 2450. But when you see the transportation cost after calculating the northwest corner method, it will be 3700. But after optimizing the solution, we have got the transportation cost as 2450. So this is the speciality of Modi method, where we will be scrutinizing the initial basic feasible solution to optimize or to minimize the transportation cost. So I hope you all like this video. If you like this video, do subscribe to the Kingmakers and share this with your friends. Thank you all.